Advanced Algebra 2 students, this is Mr. Hale, and these are your 3.1 application notes. Today we're going to be looking at applications of solving systems. So lots of story problems today, so here we go. Let's buckle up. All right, so we're going to define variables. We're going to write a system, and then we'll solve it using various methods and explain what that answer means. So here's our first one. Tyrell and Dahlia bought some pencils and pens as well, and you can see how many they bought and what it cost. It says to write a system of equations to find how much each of those cost. All right, so let's do this. Let's start by defining variables. You can use any letters you want. I tend to go X and Y unless there's a reason to do something different, and sometimes there is, and it's fine. But let's say that X is number of pens and Y represents the number of pencils. The reason I'm doing that is just simply because in both the case of Tyrell and Dahlia, it says pens, then pencils. So here we go for Tyrell. We know he bought 4 pens, 5 pencils, and he spent $6.71. Dahlia made a similar purchase, but she went with 5 and 3 and spent $7.12. All right, so we've done part one. We've written our system. And so our next job is basically to pick a method and solve it. And although this one might not be the one, it might not be the easiest choice for you, but I'm going to use elimination on this one. We tend to use elimination quite a lot. And I can multiply the first equation by -3, the second by 5, and we'll rewrite these. So I'll have -12x minus 15y is equal to, and 6.71 times 3 gives us -20.13. For the second equation, we'll have 25x plus 15y. And if you didn't catch it already, right here is the reason why I'd like to, why I multiplied by 3 and 5. Those were my numbers of choice, and this will give us $35.60, or you can just write 35.6. That's fine. Now, as you know with elimination, what we're trying to do is get rid of one variable. By adding these two equations together, we'll lose our y values, and we'll have 13x equal to $15.47. And one quick step of division then tells us that x would have to be $1.19. Now you can plug that number into this equation or to this equation. It doesn't matter. And either one you plug it in, you're going to get 0.39. Okay, as it said earlier, we need to attach meaning to this. So let's put some meaning, and that would look something like this. It costs $1.19 for pens and 39 cents, which I'm going to write it as $0.39 for pencils. That's it. Let's try another one. Suppose you had just enough money in coins to pay for a loaf of bread that's $1.95. We have 12 coins. They're only dimes and quarters. All right, so I'm going to change methods on this one, and we're still going to start by defining variables, but I'm going to switch from using elimination. I'll use substitution on this one, and we'll see why I might choose that as we set it up. That's how I'm deciding to define these. If you want to use Q and D, that's completely fine. Just make sure that you define them. It's really, really important first step. I know this is actually sort of the second thing that it says, but it's an easy one to me. You have 12 coins. That's x plus y. Quarters plus dimes equals 12. Okay? The second equation is slightly more complicated. We have to consider value. Well, we know that a quarter is worth 25 cents. I'm going to put it in terms of dollars and do 0.25x. We know that a dime is worth 10 cents, so I'm going to do 0.1x. And between those, we have to add up to $1.95. Okay, now as I said a moment ago, I will use substitution on this one. So I can let's solve for y here. So y is equal to 12 minus x, and then I'm going to plug that in. Did you guys notice my typo here? I'm trying to cover it up real quick. I had 0.1 y there, not x. I don't know where that came from. All right, but we're going to plug that value in right there and rewrite this equation. So we'll have 0.25x plus 0.1 times 12 minus x equals 1.95. And we'll do some distribution. 0.25x plus 1.2 minus 0.1x equals 195. I'm going to combine these like terms. 0.25 minus 0.1 would leave me with 0.15x, and I'll go ahead and subtract as well. 0.75, and division quickly gives me 5. Now I'm definitely going to plug that back into the first equation. X plus y equals 12, and that gives me 7. So the answer to this is, it says to find how many of each we have. So you could just simply say something like, I have 5 quarters and 7 dimes. And on to number 3. So a zookeeper is creating mix to feed some prairie dogs that has to have the right amount of protein. We have two feed A's, two types of feed. One has 12% protein, one has 5% protein. How many pounds of each does he need to mix to get 86 pounds? That is 9% protein. Now, my experience has been that these mixture problems like this are always the ones that are the toughest for students. So let's go ahead and kind of take it easy and make sure we're following along here. Again, we need to start by defining variables. I'm going to start by saying x is the amount of feed A. Now, I know you might be tempted just to say, let's use A and B as our variables, and that would be fine. The only issue is I'm looking ahead and I'm going to choose the graphing method on this one. And I'm doing that because I just want to show you all 3. So again, if you'd prefer to use a different method like elimination or substitution, then using A and B as your variables, totally fine. All right, so I like to start with the easy equation, which is, I know we have 86 pounds total. So that tells me x plus y equals 86. Okay. The other one is about protein. So if you look at feed A, it's 12% protein. So that means 12/100ths of feed A is protein. It also means, if you see that feed B is 5%, that 0.05, let's try that again, 0.05 hundredths of Y, or which would be feed B, is protein. And then here's the part that gets people. It's always this right here. 9% protein we know is 0.09, but it's 9% of what? And this is what people miss. It's 9% of the total. Percentage times amount, percentage times amount, percentage times amount. So you have to include that 86 there as well. All right, and just using the calculator real quickly, 0.09 times 86 is about 7.74, just FYI. Now, here's the thing. If we want to put these on a calculator, we have to actually rearrange so that we're in y equals form. That is, if you're using the TI-84, which is what I'm going to show you on this one. So we're going to use the graphing method. First equation's not too bad. I'm just going to write it as y equals 86 minus x. Second equation requires a little more work, but here's how we can do this. We know it's 0.05y equals, and I just mentioned this number, 7.74 minus, and so I'm subtracting the 0.12x. Now, if I want to graph it on my TI-84, I have to go ahead and divide both sides by 0.05. I don't love everything about the TI-84, as I've mentioned before, but this is one thing I do like. I don't have to go and try to clean that mess up. I can graph it just as it is. So I'm getting out my calculator. I think you can see it right there, and I'm going to hit y equals. Notice that my plot 1 is turned off. If yours is on, make sure you turn it off. You don't want that to be a distraction. Clear out any old equations you might have. I'm going to go ahead and use that fraction key. Why not? It's available. So that's at F1, excuse me. And I'm going to type it in, 774 minus 0.12x divided by 0.05. We're really going to have to think about the window just a bit here. And here's my clue. If I think about this, I know my x and y intercepts are both at 86. This comes from the knowledge that x plus y has to equal 86 for this graph. So if you have 0 of one, you have 86 of the other. So I know if I set my maximum values in both the x and y direction at 86, and I'm going to set minimum at 0. You could argue maybe you could go a little bit further, like go negative just a little bit, just so you can see the whole first quadrant, and maybe go a little past 86. But I'm pretty sure this is going to work for us. All right, so let's see. There's the first line. And that's good news. What we just found right there, we have an intersection. And if you recall from our calculator work, we've learned that if you go into the calculate menu, which is just above trace, you can find intersections with option 5. And we can choose our two lines. The guess isn't super important. We can just put a number there and roll with it. And this gives us our value. Okay, now you'll notice that these numbers are fine. They do add up to 86. They're definitely not pretty though. That's one thing about math. It's not always pretty. You see those numbers? 49.14, 36.86. Well, that's okay. And the zookeeper here can approximate that. So the zookeeper needs about 49.14 pounds of feed A and 36.86 pounds of feed B. Okay, so again, not the prettiest numbers. That probably wouldn't have been very fun if we had chosen the substitution or elimination route. As a matter of fact, I think for being honest here, which we usually are, I think you'll find that the graphing method with application problems has a lot of advantages. One of them being we don't care if the numbers are nice and pretty. And one other side note, I want you to be very comfortable on the TI-84, but there's a reality that I don't want to try to cover up, and that is you can graph from on Desmos in standard form, just like this original equation was, and you'll get the exact same answer. All right, but that'll be our secret. Don't tell anybody. It's just you and me talking about this. It's off the record, all right? All right, let's keep going on. All right, for number 4, it's a pretty similar problem to number 3. Here's what I want you to do. When I finish talking right now, I want you to pause the video and do it on your own, and then hit play and compare your answer to mine so you can see, what I did wrong. So pause it now. All right, welcome back. You can see my work right over here. The first equation I came up with had to do with total amount of the fruit drinks combined, 24 kilograms. That's a lot of fruit drink. And then the second one had to do with just the percentage of sugar. So 4% of drink A, 8% of drink B, and we wanted to create 5% drink and 24 kilograms. I can only hope that we're selling this drink and not drinking this. 24 kilos of 5% sugar fruit drink is not a healthy decision. I'm going to go out on a limb and say that. All right, so again, here's the answer, and 18 kilos of drink A and 6 of B. You can choose that by the method of your choice. Again, graphing's great, but if you want to use substitution or elimination, absolutely. All right, let's look at number 5. You have $22 in your bank account and deposit $11.50 per week. At the same time, your cousin has $218 and he's spending money and you're saving. You win. Write and solve the equations to find out how many weeks it will take for you to have the same amount of money and how much money that will be. All right, so here's the equation for you. The total amount of money. You know what? We should define variables, shouldn't we? Here we go. Y represents total money. X represents number of weeks. Okay, so our equation is y is equal to, well, we only have $22, but we're adding 11.50 per week, and our kind of dumb cousin has more money than us right now, but he's just going to go ahead and spend it all, like the smart dude that he is, $13 a week to make that happen. All right, and we want to find out when we have the same amount. On this one, I think substitutions actually, it's screaming substitution, and the reason is we have y equals and we have y equals, and that makes it quite simple for us just to set these essentially equal to each other. So I'm going to do 218 minus 13x is equal to 22 plus 11.5x. I'm going to add 13x and subtract 22 from each side. And one quick step of division tells us that x is equal to 8, and that's great. And then so it's only going to take us 8 weeks, and when you plug in x equal to 8 to either of these equations, you get y equal to 114 is the number I have. So we got to put some meaning to this, right? So after 8 weeks, we will each have $114. And then after that, I'm going to have more money than my cousin. I'm already a little over the time I'd like to spend, so for these last three, I'm going to talk you through setup, and I'm going to let you solve them on your own. I will put the answers on here so you can check it, but on each of them, once we get the system set up, hit pause and solve it. Choose your method. All right, so on number 6, we're investing money into 2 accounts. I'm going to use the variables x and y again. So this is the amount at 4%. That will be x. And then y would represent the amount of money invested at 5%. Wouldn't you just invest it all at 5? Okay, sorry, never mind. All right, so here we go. We know the total of $12,000 is invested, so x plus y is 12,000. And that's just pure investment. Now the interest looks like this: 4% of x plus 5% of y would give us the $550. Again, pause the video real quick and find your solution to how much was invested in each amount. All right, I'm hoping you came up with the same result I did. $5,000 invested at the lower rate, $7,000 invested at the higher 5%. Again, you don't normally know those interest rates when you put money in, so I was joking about saying why not put it all at 5, because sometimes we just don't know. Okay, all right, same setup here. This time a farmer problem. Hopefully you've been out to see some sunflowers this year. So we have a farmer growing sunflowers and flax on his 240-acre farm. And I kind of am going to skip the next sentence when I read and say how many acres of each crop. Okay, well I'm going to say X represents acres of sunflowers and Y represents acres of flax. Sometimes just jumping ahead to the last sentence on these is really helpful, because it almost always tells me, what am I looking for here? What are my variables, in other words? So here we go. We know we have 240 total acres. And if you notice, I haven't even read the second sentence yet, and I've already defined variables and written an equation. It's debatable if that's the smartest method, but I don't know. I think it's an all right method. This year he wants to plant 80 more acres of sunflowers than of flax. So if I take the number of sunflower acres and I subtract the flax, I should get 80. Hey, I hope you see which way this one's set up to be. But pause the video, solve it, and compare our answer. All right, welcome back. I'm really hoping that you saw this one and saw that the elimination method, man, it was just screaming elimination. Plus y minus y. Oh man, use elimination. So anyway, that's what I did. And I got that the farmer needed 160 acres of sunflower and 80 acres of flax. All right, the problem we've been looking for, the last one. Write a system to find the number described. All right, so this is kind of a tricky one, a different one. You have to think about place value. And this number, the ones place digit, is 1 more than twice the tens place digit, and also the value of the number itself is 2 more than 5 times the ones place digit. That's a lot of words. You have to read slowly and think about things. All right, let's do this. Let's call x the ones place, and you could switch this around, and maybe it's arguable that you should and do tens place then ones place. It's completely up to you. All right, and so here we go. Ones place and tens place. X represents ones, Y represents tens. And it says that the ones place digit is, and when I see that word is right there, I'm thinking equal sign, 1 more than twice the tens place. Okay, well that's 2y plus 1, or 1 plus 2y. Order's not important there. All right, also the value of the number itself. Well, how do we get the number itself? Well, that would be x plus 10y is the number itself. Now, where is that coming from? Okay, x is the ones place, y is the tens, right? So if you take the tens place number and multiply it by 10, you get its actual value. Okay, then it says it's 2 more. I'm just going to write that, 2 plus 5 times the ones digit place. So we get 5x. All right, now that one, it's going to take a little work on cleanup before you can go ahead and solve it, but do that and then compare your answers, and then we'll wrap this up. All right, welcome back for the last time here. The number was 37, and when I solved that system, I got 7 comma 3 as the result. Again, choose your method. You might look at that and see substitution would be a good method because I have an x equals, but you can use literally whichever of the 3 methods you want. I'm not picky about that since the instructions don't specifically state so. All right, so 37 is your number. I always like to find that answer and then go back and read it again. Hey folks, I hope this lesson makes sense to you. I know it's a little lengthy, but I think seeing some of these examples is helpful. So be like the cool kids and come to class ready to work.